Okay, just wanted to work a few more problems just for a little extra practice that are a little bit different than the ones that we've had in the homework and in the notes. Let's consider that we have a circuit like this. I have an unknown voltage supply, a power supply or battery. Don't know what it is. And I have some resistors hooked up like this. I have a 3 ohm and a 6 ohm here, and then those are in parallel. I have two 1 ohm resistors here and here, and then I have a 2 ohm resistor here. And I know that through this 2 ohm resistor that I have a current equal to 3/2 of an amp. And I want to know, what is this voltage supply, what is this power supply that's provided right here to provide this circuit that will give such that it has 3/2 of an amp through that 2 ohm resistor. Well, let's start just by finding the equivalent resistance of this, or at least we'll find the equivalent of these two, and then of this branch. Now these two branches are in series with one another. Of course, the 3 and the 6, that's 1 over 3 plus 1 over 6. That's equal to 2 ohms. So I'm going to have a 2 ohm resistor here. I can combine these two resistors, 1 plus 1, and that gives me 2 ohms. And then combining it with this 2 ohm and this 2 ohm resistor will give me 1 over 2 plus 1 over 2. And that's equal to 1 ohm. All right, so that gives me then this 2 ohm resistor in series with a 1 ohm resistor. Okay, and then I don't know what this voltage is. However, if I look at this, I can figure out what is the voltage across this 2 ohm resistor because I know its resistance and I know its current. So that voltage is V is equal to IR. That's equal to 3/2 of an amp times 2 ohms. That's equal to 3 volts. Okay, but if I have 3 volts across this resistor, that means I also have 3 volts across these two resistors because they're in parallel. And further, it means that I have 3 volts across this resistor. Okay. Now, if I have 3 volts across that resistor, that means that I have a current through this resistor of V over R. That is 3 over 1 equals to 3 amps. So I have 3 amps through that 1 ohm resistor. Because resistors in series all have the same current, I also have 3 amps through this resistor. And I have 3 amps coming up through this circuit in this way, the total current. So I have 6 volts then. V is equal to IR. That's 3 amps times 2 ohms is 6 volts. And so my total here will be the sum of these two voltages, which is equal to 6 plus 3, which is equal to 9 volts. Now let's try another one. Let's say that I have a circuit that looks like this. I have an 8-volt battery. I have some resistor here that's unknown. And then I have 2 additional resistors. This will be 4 ohms. 4 ohms. I don't know what this resistor is, but I want to know it. And the other piece of information I have is I know that this is 4 volts. Okay, so if I have 4 volts here, that also means I have 4 volts here because these two are in parallel. Let me redraw this circuit actually, it might be a little easier to understand. This is my resistor R, and then I have 2 resistors in parallel like that. This is a 4 ohm, it has 4 volts. This is 4 ohm, and because it's in parallel with this resistor, this one also must have 4 volts. If I redraw it again, combining those two 4 ohm resistors, 1 over 4 plus 1 over 4 is equal to 1 over a half, that's equal to 1. That's going to be R, 1 ohm. I have 8 volts here, and I know that I have 4 volts here. So, because I have 4 volts right here, and 8 volts right here, I must have 8 minus 4 equals to 4 volts here. Because those two have to add up to equal to 8. So I have 4 volts here. Okay, so because these two are identical, that means that the resistances must be identical. So this resistance then is 1 ohm, which is the same as this resistance. Do one more. Let's say that I have a circuit that looks like this. I have a power supply, a 4 ohm resistor, a 2 and a 3 ohm, and a 4 ohm, a circuit that looks like this. Let's say that I have a current equal to 3 amps, and I just want to know what is this voltage. This was pretty simple actually. Well, it's not simple because when you look at this you might not see a circuit as we've been seeing them. But let's first just trace out the circuit beginning here and then going through. So first I'll redraw my battery. I'm going to come up here and I'm going to draw my 4 ohm resistor right here. Up to this point, I haven't gone through any junctions. Now when I come to this point, I do get a junction. All right, and it breaks into 2 pieces. So I have 2 arms to that junction. On this top arm, I have a 2 ohm and a 4 ohm before it comes back together. 2 ohm, 4 ohm. And then on the bottom junction, I just have a 3 ohm before it comes back together. So these 2 circuits are identical. I want to know what is this voltage. I know that this current is equal to 3 amps. Now simply all I have to do here is find the equivalent resistance. This is 6 ohms, 2 plus 4 is 6. And then 6 and 3 in parallel. 1 over 3 plus 1 over 6. That's equal to 2 ohms. And so then I would have a 2 and a 4 ohm in series. So 2 plus 4 gives me a total equivalent resistance of 6 ohms. So I have this power supply. I have one 6 ohm resistor, which is the equivalent of all of this stuff right here. And I know that I have 3 amps of current. And I want to know this voltage. Well, that voltage is equal to the voltage drop across that resistor, which is equal to I times R, 3 amps times 6 ohms, which of course equals 18 volts. All right, so my voltage of my power supply is 18 volts. Let me also remind you of, I have some common numbers that I like to use for capacitors in series, resistors in parallel. If I have either these, this is dealing with the 1 over R plus 1 over R plus ... So for example, if I have a 3 and a 6 ohm, that gives me 1 over 3 plus 1 over 6 is equal to 2. Right? These are just common numbers that I like to use. You don't have to memorize them, of course, but if you sort of are familiar with them, it will help you as you're going through the test questions so that you're not fiddling around with fractions when you really should be thinking about the circuits. Let's see some others. 1 over 4 plus 1 over 4. That's 1 over 2/4, or 1 over a half, which is also equal to 2. 1 over 2 plus 1 over 2. That's equal to 1 over 1, which is equal to 1. I have 1 over 3 plus 1 over 3 plus 1 over 3. That's 1 over 3/3, or equal to 1. Also, let's see, 1 over 2 plus 1 over 3 plus 1 over 6. See, that's 6/12 plus 4/12 plus 2/12. 6 plus 4 plus 2 is 12. That's 1 over 12/12, which is equal to 1. These are just some common fractions. Again, it'll save you time if you know these, or if you're at least familiar with them, so that when you write them out, you don't have to go through and find the greatest common denominator and adding up the numerators and then simplifying the fractions, or worse yet, even putting them in your calculator and maybe making a mistake en route. But if you just know that these are equal to these quantities, that will probably make you faster and help you to do better in the exam.